Welcome to everyone joining us today for our 40th session in our Essential Skills series. The title of this webinar being Applications of AI in the Built Environment. Just to note the usual, first of all, this will count for an hour of CPD, and just to ensure that you record that CPD on your dashboard or on your profile. We are joined by Dr. Oisín Cawley today, who I'll give you a brief introduction to in a minute. But just to note that the webinar is an hour long. We'll aim to leave as much time at the end for a Q&A session. Just to use the Q&A function on Zoom for any questions that you have for Oisín, and we'll hold them off until the end and get through as many as possible. Just with the chat function, if you can use that only for any technical difficulties you might have. So if there's an issue with the audio or the visuals, do let us know. And if you can't access that, there's the email address on the screen there, or worst case scenario, the phone number to call. But everything should run smoothly. And then just at the end, any of our attendees, your feedback is extremely valuable to us and our presenters, and we do share that. So we'd really appreciate if you could complete the online survey that you'll be directed to at the end of the webinar. Other than that, I'll just introduce Oisín before I hand it over to himself. So Oisín came to us through some funding through the South East Technical University, who've kindly offered some of their lecturers time to cover some interesting topics for essential skills. So Oisín himself is a full-time lecturer and researcher in computing at South East Technical University in Carlow. He has a Bachelor's of Science from UCD, an MBA from DCU, and a PhD in Software Engineering from UL. He's worked primarily in software development roles in the IT industry, and that's across Germany and Ireland over the last 17 years. And he currently lectures both undergrad and postgrad in South East Technical University in their computing courses. He's also the program director for the Masters in Science in Applied Artificial Intelligence and a co-founder of the Advanced Machine Intelligence Research Group at C2 Carlow. So without further ado, I'm going to stop sharing the screen and hand over to yourself, Oisín.
Right, let's get the show on the road. So thanks very much for the introduction, Eve. And what I wanted to do today, just with we got some background there from Niamh and the folks there, just in terms of the audience we have on today, and it's a cool subject, artificial intelligence, and so the idea really for this sort of lunchtime slot was to try and, I guess, pack in as much as I can into a 50-minute slot, if you think about it, and just to try and give people a nice introduction, a nice overview of artificial intelligence, and I think importantly the applications of it now. But to do that well, I think we need to sort of just go back a little bit and just to understand, I guess, what the general understanding of artificial intelligence is now. And so that's the idea anyway. Just do a bit of an introduction, some of the key concepts, and then look at, okay, how is it in reality, how is it being used, and where is it going? So it's a fascinating topic to be involved in at the moment, and I teach it here in undergraduate and postgraduate level, and it's changing all the time, or not so much changing, but advancing all the time, which is phenomenal. Okay, so that's the background of what we're doing today. So to kick off, this is not a philosophy lecture either, right? So artificial intelligence, you could talk for days about what people think it is and what it is, and So in our context, what we need to try and just to come to an understanding is that if you're following the news and you're hearing and reading all about AI this and AI that, it seems it can be absolutely anything, and I always like to ask the question, is if we have a nice scientific calculator, ask the question, is that an AI? And that's you know um, if I think back on the days when I got my first calculator, and I was using it to in exams, and it was doing stuff that I was never going to be able to do, right? So get the square root of a number or multiply two big numbers together, in an instant, right? Um, so is that, and it's certainly it's artificial, right? You would think it's intelligent, sort of. So maybe it is an AI, right? And they've been around for a long, long time, right? So in general, though, there is no clear consensus on a particular definition. Okay, there's lots of definitions. So in general terms, I think what we really understand or want to think about when we mention AI is something that sort of resembles how humans um, think and act and do and can process things. All right, but some of the key things are in this definition here. You see, learning, being able to learn something. That's a fundamental um, concept for humans, right? It's and for all creatures, right? Reasoning and problem solving, though, they're sort of stepping up the ladder, right, in terms of intelligent behavior, perception, you know, being able to perceive, right, and whatever that is exactly. Okay, so really, we're looking at trying to mimic or trying to do what humans do. If we want to make a sort of a simple definition or um, common understanding of it, right? And when I say it can be anything these days and it's thrown around, a lot of people, if you ask them about AI, say this is the type of thing, right, they think of, right? Um, my favorite character, Data, there, right? Um, but clearly fiction, okay? Um, but artificial intelligence in real life, and I had to look around and I had to think to see, well, what would we, probably say is artificial intelligence these days? Um, and certainly when we see programs or applications starting to beat world chess masters and also the world Go master, if anyone is familiar with Go, that was another big thing. Um, then we're starting to sort of take note and say, oh, hold on, this is this is something, right? So, I mean, that's one thing, and then we have the industrial revolution, and you have the robots that came in, and manufacturing was turned on its head with that. But then we're moving into the modern world where we have facial recognition on our cameras and self-driving cars, and I put up the Mars rover up there as well, and we can ask, well, is that an AI? Well, I put it up there because if you think about it, it takes, something like 20 minutes for us to send a message to Mars. So the guys in NASA, if they want to control the robot or tell it to do something, they send it a message, and 20 minutes later it gets it, and 20 minutes later it can respond back with an answer to that. But in the meantime, right, that's a lot of time. What is it doing? It still has to do its own thing. It still has to make its own decisions, right? It's not going to stop and wait for the next, for 40 minutes before another conversation happens. So it's autonomous, and that autonomy, like a self-driving car, has to have some, human qualities in there about being able to perceive and see and act and decide on things. All right. So they're sort of nice, fancy ones, examples, but also sort of underneath the AI umbrella, I would have things like this, and some of these are interesting because you say, well, hold on, I've been doing this for years, and the answer is yes, but I still think this is where people are going to say this is where AI is currently happening and going to continue to improve. Um, so demand forecasting, right? Logistics, supply chain optimization, These are all things that have been done for donkey's years, but AI now is improving the ability to do these things. If we're buying something, right, what is it recommending to us, right? It has a whole pile of information about us. It knows a lot about us, a lot more than we think it knows, and recommending stuff. Non-playing characters, computer games, right? Go back to Pac-Man. It's probably the first AI in a computer game ever. But then we get into more sort of high value things like risk estimation, right, in financial services, or um, we're all familiar with digital assistants, right, or autocorrect. We're all sick of hearing about ChatGPT, but it's even, it's improving the whole time. Chat GPT 4.0 or 4.0, whatever they call it these days, is another improvement over the original ChatGPT. So it's phenomenal. Google Maps, been around a long time, but the things that Google Maps is able to do now, because it can start pulling in different bits of information and putting that all together to determine a route, is pretty good. Social media feeds, where do they all come from? Why are we fed certain feeds? Security and surveillance, smartphones, smart, everything is smart these days, right? And the last one, that computer code verification, that was always a big thing with software development. Is your code bug free? How do you know? Have you tested it? And now we're getting to the case where we have AI tools that will look at your code, and it will verify that it's correct. That's a big thing. So just some of the terms that are, I think, bantered around, and some people maybe just don't understand, or just lump them all together. And certainly you read some stuff, and you see people using terms that just, they're just not right in the right context. And so we're going to have a look at a couple of these, right? In particular, I want to look at a thing called data science and machine learning and artificial intelligence. Those three are very important, and overlap. And even the term data science, I mean, that's a relatively new term. That has, I suppose, really, it took the world by storm. Data science, yeah, analyzing data, and making decisions and finding things out. But data science is, as I said, a relatively new term, if you like, and it has been happening for hundreds of years. If you're a statistician, I mean, you would say, well, this is what we've been doing for centuries. But anyway, so our modern term for data science, and clearly data being the key component in it, right, has a couple of pieces to it. So we have this this mathematical component, right? So that's the well-known statistical approaches. Notice we're talking about structured and unstructured data, which is a key thing to keep in mind. And whenever you start to look at any sort of artificial intelligence, you're always going to come back to data, and what is your data. And we see that again. We have computer science here with some visualization, how to present, how to sort of interrogate data in that perspective. And then we have the last one, which is probably very key within the data science topic, is having the knowledge about the context that you're dealing in, right, and being able to interpret and make decisions with that sort of what we call domain knowledge. So all of those mixed together, that's what we understand by data science. So when we look at, we already sort of had a high definition of artificial intelligence. Machine learning now is, and I just highlight there, it's we're trying to imitate the way that we as humans learn things, right? So you think of a child, it learns how to pick things up, it learns how to walk, it learns how to speak, it learns what's good, what's bad, what's danger, and that's what machine learning is. We're trying to just mimic that. So that's its particular focus. Whereas AI refers to the ability to act and make decisions like humans. The machine learning part is, okay, well, how do we get there? How do I become that smart in terms of an algorithm, right? And then I just thought it was important here because again, these terms pop up every now and again, and people may or not, be aware of them. But for machine learning, in principle, there's sort of three types of machine learning, right? And the big terms are supervised learning, unsupervised learning, and reinforcement learning. And to be honest, predominantly, all of us probably are going to be working with this sort of supervised learning. And really, that's what that simply means. And if you were a statistician, you're looking at regression and classification and that does those types of things. Okay. But it simply means that I've got a whole pile of data. I know what this data means, and I want to put a model on top of that. And that's how I'm going to learn. I'm going to learn from all this previous data that I know and I understand what it all means. So just anyway, you can, if you look at this slide, you can come back to this but you'll see somewhere you just have to do a search on the internet and you'll get something similar. But it just puts a lot of different things together there into one sort of picture. And then I guess going deeper into what we call deep learning is really machine learning, where we use what we call artificial neural networks. And of course, if we're going to learn like humans, well, we look and concentrate on the way that we do it, right? The mechanisms, the physical nature of our intelligence, which is our brains, okay? And the network of neurons that is our brain. And this is where artificial neural networks were, an artificial sort of brain, if you like, where we try and simulate what neurons are and how they work. And so this sort of deep neural network here is trying to mimic that. And so this is just one way of machine learning, these artificial neural networks. But if you talk about this, then this is what they call deep learning. So we're using these, the deep comes from these deep layers and layers within the network. Okay, a deep neural network. Of course, you can have a very shallow one or you can have a very deep one. At the deeper ones, you've got more and more connections. So you can see just all those connections there. That's where the complexity of artificial neural networks comes. And if you imagine that each one of those connections holds a piece of information, and an important piece of information once it's taken into account with all the other connections, let's say, in that layer. And that's, in general, that's how our neural networks are architected, if you like. Okay, so artificial intelligence make predictions and even learn from our experiences. And then just to mention these two terms, weak AI and strong AI. And typically everything that we're looking at nowadays is weak AI, all right? We have an artificial intelligence, we have an algorithm or a collection of them, but they do one thing and they concentrate on one thing. And they do it very well. And that's what we call weak AI because it's very selective, all right? The strong AI is like humans, all right? We can do so many things simultaneously, multitask, and do lots of different things all at the same time with the one thing, which is our brain, right? And so that's what strong AI is trying to achieve, all right? And in AI terms, we call the general artificial intelligence, or depending, sometimes it's artificial general intelligence, but you get the idea. And that's where all the modern research is. Can we get to the stage where the brain is mimicked in an algorithm so it can do lots of different things? And we are so far away from that still, even though there's lots of headlines about different things. So just to sort of stick it all together, if you like, you can see the different layers. It's all wrapped up in artificial intelligence and data science. Then, sort of as a process, is there and may or may not use any of this stuff. And so they're just as a put it all together figure, if you like. Okay, so I did mention that no matter what you do with artificial intelligence, and really all we're doing is trying to make a model of something. We're trying to model the world, right? And we have this input data into a model, and then the model is trying to figure out what that data means. So we have to have this data, and the more data, the better the model, and that's the simple reality of it, right? And that makes perfect sense, right? Because I can learn better the more data I'm given. And you may have heard the term big data. Big data just means I got tons and tons of data. And I suppose historically, all this big data, nobody knew how to handle it or manage it, or used to take chunks of it and then work on that, and then other chunks and put them together. Then, and whereas we've come to a point now where we can build these AI models that can take tons and tons of data all together at the same time and feed them in and make sense of it all. And that's really where I guess it gets exciting. Okay. So that's why everyone is interested in big data, and you have your big data centers, storing all this data, and huge amounts of just mind-boggling amounts of data. And a lot of the data people don't yet know what to do with it, but it's there. And sooner or later, people will find a way to use it. So really, that's what we're doing. We're trying to model the world, and then the model is able to interpret um, new data that it hasn't seen before, and that's the key. Okay. So this idea about the data, and you ask the question, well, what is it? What is the data? And you know what? These models, these algorithms, they don't really care. And in fact, they don't even, if you give it a lot of data, it doesn't even know what this data is, and it doesn't understand it. All it knows is I've got a pile of numbers. And you know what I can do? I'm going to try and make patterns out of this. I'm going to try and figure out what this all means. And it doesn't actually derive any meaning for it. It just produces more numbers at the end. So whereas we have somehow internally the ability to understand this stuff, these they don't understand it. It's all numbers. So if I just give you examples here, that's we got data from blood tests, and with this set of blood tests here, this person was diagnosed with a cancer. Okay, lots of blood tests, and whether or not they were cancer patients. It doesn't know it's blood tests, and it doesn't know that a 1 means cancer and a 0 means not cancer. It doesn't know. The same image recognition, does it know that it's a cat that it sees in the picture? No, it doesn't. It sees some sort of pattern in the data, and we tell it, by the way, that's a cat. It doesn't know what a cat is, right? So the data is almost it doesn't matter to these. We're the ones that make the association with the inputs and the outputs, and we have the understanding. So that's, I think, always an important thing to remember. At the end of the day, who makes use of this data and how do they make use of the data? Well, it should be us, because we're the ones to understand it. Another algorithm or program doesn't really understand it. So we have insurance history and a risk rating for somebody, right? Building data, house plans. It's all the same. Okay, so that's just to give you a good idea about how everything sort of ties together in the world of what we're calling artificial intelligence. And one thing, as I said, we have lots of is data. And if you ever get into any of this model building, then one of the first questions you're going to ask, well, what am I trying to model? What data do I have? And in a way, that's sort of where data science comes back into the picture, because data science as a process is about looking at data and then getting the data ready for analysis, if you like. It's a big part of it. Okay, what else have we got? Predictive AI versus generative AI then, and I'm just going to move on a bit here. So just to draw the distinction, the generative AI is a relatively new thing. Let's just put it like that. Predictive we've had for a while. Makes predictions, predictive, right? Generative generates new content, something brand new that wasn't there before. That's a big difference. The data, so for prediction, is we have our data sets and we know what it is. The generative typically is taken from lots and lots of different places and pulled together. And the generative stuff takes a lot more training. if you like. But you see the type of data here, you can mix, they're starting, let's say the likes of ChatGPT and stuff, they can mix now audio and code and images and text and all different sorts of things. Whereas the predictive is still very sort of weak AI-ish, one particular thing, and I'm going to do that very well. Okay, so moving on. And I just want to, you can come back and look at this because I think it's a great sort of summary of a lot of things. And you know, I took this from the aoproptech.com, and I thought it was very good. But what I want to draw your attention to is, I guess, up at the top, we have sort of moving left to right, the second row, we have collection and digitization, right? And what is that? That's the collection of the data. So any AI system is going to have the data, right? Question is, where am I getting the data? And if you like, data science is all about this, collecting the data, cleaning up the data and making sure it gets ready and appropriate for what we want to use it for. Okay. The second piece, column on that row, then the analytics. This is where we apply some sort of analysis to the data, and this is all the AI algorithms that we talk about, including, you know, artificial neural networks in here, but a raft of algorithms and analysis tools, some of which have been around for a long time, some are relatively new, but they're all being, you know, clumped up there together now. And then we have on the far side, the what do we do now, right? The decision making, and they just call this here AI automation. But this is for us anything that we want to do as a result of the data gathering and the analysis of it. Okay, so in what we call the built world transformation, right? Building, right? Whatever it is, building stuff. Okay, then the automation can be, you know, whatever we want it to be given whatever data we have. Okay, and, you know, video analysis, machine analysis, different things in different contexts. So just on to the next one here is another one again from the same folks, but it's a mapping of AI technologies that have started to be used, I guess. And this is these are all companies that have started up, and you can see heavier green, more companies starting up doing that sort of thing. I know it's hard to read, and I don't expect you to read it all, but you could come back and have a look. But, you know, we have things up here: agriculture and software, climate risk, construction, energy assets, hospitality, smart building, smart city, and just, you can even just see where the heavy greens are. And in particular here, I'll just highlight the greatest spread is in construction, which is, now this is around the built environment. Okay, so this is not every industry. So, but AI employed across robotics, remote sensing, the Internet of Things, and computer vision. But anyway, so I'm not just to present it to you so you can see where, you know, these are actual companies now that are starting up and getting involved in that. So it's hot stuff, right? It's happening. A lot of people getting involved, getting excited, starting up companies. There's business happening in these areas, right? And just in terms of some figures that we had here in dollars, so obviously an American source, but 49 billion in venture capital in 2022, right? It's a lot of money. In AI, okay, just AI related stuff, right? So no industry is going to be spared in this in this push for increased use of artificial intelligence. So this company LMRE they did a poll on their members, and it was about real estate. Where do their members think AI was getting traction there? And you can see property management being high, agents and brokers and the roles that they do, and then actual construction operations 25%. So we can see that we're seeing the reality is that on the ground, people, you know, their understanding of AI is hitting in those particular areas. So and just to move it on a bit, I'm going to keep going here. So prop tech, property with technology. which is the buzzword there in that sense, right? And as I said, a lot of things getting lumped under the AI tool, but these are the sort of things that we can now, lump in there if we like, but that's what they're going to be called, right? And we'll see some more of those, right? So there's a link there to that source I have. In 2021, witnessed the highest value of prop tech investment, about $24 billion. All right, that's in property technology, right? So clearly somebody is taking notice, right, that there's money to be made in there somehow. So I just wanted to have a look quickly, and I'll go through some of these quick enough. So how do we see AI affecting? In particular, I'm using the built environment industry just as a good example, all right? But what I want you to be able to take away from this is that, listen, the process for using AI in almost any case is the same. Okay, what is a problem that I have that I'd like to try and solve or make easier? Do I have data about this particular problem? Where is the data? How am I going to get it? What do I have to do to it? And then how am I going to analyze it? And what am I going to do when I have analyzed it? What are the decisions out of it? And as I said, the algorithms do it. They don't care what the data is, right? It'll just give me the data. I'll analyze it. Okay, you tell me what you want, and I'll do it. So we have here a broad sort of scattering of things that we'll run through. So investment, all right. So we're always going to be looking at what's the data. In this case here, the data for a built environment, right? Historical, data, market trends, economic indicators, social factors. And the great thing I think about, let's say, the likes of the neural networks is that we can start bringing in these different components into our analysis, like social factors, from places where we wouldn't have thought to garner the data, or that we didn't actually have before. So for example, even social media data that we can pull in and use in our analysis. Okay, so investment, pull in the data and additional stuff, property, site, location, meaning, etc. Right, and we can analyze that. And what we're really doing is making more informed decisions about our particular context, right? Which in this case might be property financing or risk assessment of tenants or purchasers or whatever it is, right? Automated, so we're still on the sort of the investment here, right? Automated property valuation. So enables real estate professionals, homeowners to make informed pricing decisions. So what you'll see is that a lot of these things, clearly we've been doing these things before, but now what we're finding is that we're going to be able to do them faster and be with more precision. And who doesn't want that, right? And who's going to turn that away if it's made available to them, right? What else can we do? Risk assessment, insurance, underwriting. Okay, and we have lots of data for all of this stuff. Okay, and again, what can we do? Make more accurate underwriting decisions, streamlining claims processes, provide custom-made coverage options. Now, without having to go into the nitty-gritty of exactly how that's done, we can visualize that. We can say, oh, right, yeah, okay, so I have lots of this historical data, certainly to do with finances and insurance claims and all of that. And yeah, I can analyze that. And what the AI gurus are saying, you're going to be able to do this even better, because these models are able to pull in even more data, and more complex relationships can more easily be identified. Okay. Market demand analysis. All right. Identify emerging property markets and investment opportunities. Okay, that's all right. What else we got? Sustainability. So we have some interesting things here. Optimizing energy consumption, and that's got to be a big thing, right? For anybody who's worried about climate change and energy security and stuff like that. So currently, the built environment consumes 40% of all the energy in the world, right? Which is staggering when you think about it. But what's probably more staggering, and I didn't put up a figure on it, but there are calculations or estimates about how much you know building is going to happen over the next whatever 50 years, and it's staggering. They're talking about a city the size of New York is going to be built every month in terms of everything that's going on around the world. So energy is just going to continue to be a growing problem, right? But also 40% of the annual CO2 emissions put down to buildings. So clearly you can see that moving forward, that we got to be really careful, or do whatever we can to try and make energy efficient buildings and so on. All right. So clearly that's so we can use the AI to track and analyze reduced emissions, right? Because if we measure all this stuff, we've got the data, we can take a look at it, right? We can produce energy efficiency optimizations, right? We can also look at integrating different energy sources, and we do that with a mind to, who requires it, when do they require it, how do they require it, what do I have available, where can I get it from, and so we can help promote sustainability, and I guess cost savings in that regard. So I just came across this. I don't know if people are familiar with the ESG investing, and I have to relook and see what ESG stood for, which was environment, social, and governance. That's what it was, right? But I thought it was interesting to have a look at it, right? So AI algorithms can recommend environmentally friendly construction materials and techniques. Okay, but the ESG investing is where investors now are looking at the I think companies can get an ESG rating, and these ESG investors are looking at those companies with high ESG ratings for their investment. So that KPMG report there shows that certain construction leaders are certainly now very aware of this investment direction, I guess, for some investors. Sustainability on optimization. So what are we trying to do? We're trying to monitor and analyze our energy consumption. But not only that, what else can we measure, and what else can we bring into our equation, if you like, right? And certainly, how many people are there? Does a place have to be warmed or cooled, and by how much? I guess more people, right? Less heating or something like that. Okay. Environmental conditions in the buildings, environmental conditions outside the buildings. So we now have the ability to bring in lots more data. And we talk about, down at the bottom there, real time sensor data. So these IoT sensors, this Internet of Things, and we're all getting these smart meters installed in our houses now. How can that be used in the future? So that's what we refer to there. Property maintenance and predictive maintenance. And again, this predictive analytics has been around a while, but it's now looking at ways of enhancing the way that we do that, which is by looking at more data again, right? It's what's my problem here? What is the data that I can collect? Is there data that I'm not collecting that I could collect? Well, then that would be great. I bring that in and I help to try and make better decisions. Okay. So this is proactive, predictive maintenance, if we like, right? So we want to be able to try and look ahead and plan for potential problems that may occur, and we do predictive maintenance by by trying to, I guess, foresee problems that might occur and doing something before the problem actually occurs. So I think that's all really I want to say on this. And optimize maintenance schedules. Yeah, so that's okay. So the other item we mentioned here was around, and we saw back on that graphic before, that construction was seems to be an active area for AI development. But one of those aspects would be the actual materials that are used, and also the processes. So we now have the ability to produce these AI models that can suggest I guess designs that we may typically not have thought to use in the past. And it's just because it can now consume a lot more data, like lots of different designs, and it can produce a new combination if you give it certain parameters, and it will give you its best proposal for it. And those factors that we stipulate, or those parameters that we put on it, can be things like energy efficiency, and the amount of our carbon footprint, and so on. So we can hope that we produce these designs together with a list of materials and even techniques, then depending on where we are, that will help us reduce, I guess, our emissions, and I suppose improve sustainability. So just on that particular diagram there, I wouldn't try and build it because that was generated by Midjourney, which is an AI generating tool. So it can generate beautiful images like this, but clearly may not be actually buildable. So image generated by Midjourney. There we go. Okay, moving on. Smart homes. We have again, we have real-time sensor data, which is going to help us just gather more data about the house, right? And the more data we have, the more we can sort of predict, control, reduce, increase, whatever it is, right? And we have, in terms of smart homes, we have the property management and automation for owners or people who are managing it. For the residents, being able to, I guess, turn on things or turn off things remotely, so that I guess that's just something that we all would like. It's the convenience thing as well, right? But it also means we can do it wherever we are, whenever we are, right? So enhanced quality of living, but also contributes to our sustainable practices. And just an interesting point is, thinking millennials, right? These folks have been brought up with technology being part of them, right? And account for a large portion of the housing market. So therefore, you would expect that there will be an increase in demand for smarter homes with built-in tech and so on. Building security. So where would that be? Seeing the AI is in perhaps facial recognition and anomaly detection, again via sensors and different things like that. Okay, so decision making. Lots of data again. AI is designed to consume and model this data. What can we do then? No matter what the data is, we've got lots of it. We put it all together. We can make more informed decisions. And really, that's in a lot of lines. That's what you want to be able to do: make better decisions and make faster decisions, right? And it goes across all professions, as far as I'm concerned. Property searching. We also have the the advent of the NLP, so the natural language processing, and this is typically your Chat GPT type tools. All right. And together with image recognition now, that's becoming very, very powerful. And they've also put in, video and sound, and there's lots of things all coming together to produce very powerful models. Okay, I'm just going to keep going here just in terms of time. Some nice tools that came across here: personalized interior design. So leveraging computer vision and machine learning. So this one here in particular, we got a picture of a room, and you want it sort of redesigned, and typically you might employ, I guess, a interior designer. So they wouldn't be too happy with this one. But certainly for me as a user, when I can see something like this offers so much more. To me, to be able to customize and see how it, at a whim, change it and see what happens. The chatbots, right, are going to be everywhere. We're going to be sick of them, and it's just that they're becoming so more, much more useful because of the advances with the large language models, right? Like ChatGPT. Okay. And they're improving, right? So we're going to be able to talk to them, and they're going to be able to talk back, and that's practically there already. Okay. Tenant screening, fraud detection. So that's sort of risk analysis again. Same sort of idea. Give me the data. What are you looking for? I'll try and find it. Document processing is going to be another big thing, I think, for a lot of companies, a lot of roles. Automatically extracting information out of documents, including contracts and legal documents, is going to be phenomenal. And in fact, one of the researchers here is looking at trying to translate legal documents via natural language processing. So it's a very active research area. But I'm just going to show you this one here, which is I attended these guys here at Retrograde. Okay, so they build AI for content creators, right? But this is what they had. They had this is their company. What it did, each brand had a deal, okay, with this company, and what they would use a third party to outsource the contracts, who charged a lot of money, and it was coming up to renew this contract, which was over a six-figure sum, right? So they said, "Well, is there anything we can do about this?" So this, and don't worry too much about the technical detail, but all of this stuff down as far as contract text data extraction at the bottom, that's what they had. And the OpenAI was that third party company. And so what they did is they replaced it with OpenAI. And if you know, OpenAI is basically ChatGPT type functionality. And they would send out the contracts, electronically to ChatGPT type functionality, and it would return everything that they wanted. It would analyze the documents and give back the information. 97% annual savings. Took 10 days to talk, which is ridiculously short, and one third party who was out of a contract. So good for some, not good for others. But that's the reality. That's an actual business that did that. So amazing stuff. Okay, and again, I'm going to just skip on through some more. Intelligent space utilization. Again, do I have the ability to measure other things like occupancy and usage and other things, right? The adoption of VR and AR is quite exciting as well, right? So I can get a tour of something just by staying at my desk, right, in 3D, and move around and all of that. So construction, robotics, and a lot more focus now on some of the more heavy lifting jobs like bricklaying and welding, and even 3D printing the entire buildings. I mean, that's all real now, which is incredible. I'm just going to keep going. Just the last point here, construction is lagging in its digitization and adoption compared to other industries. So 90%, 95% of all data goes unused. So tons of data just waiting to be made use of. Artificial intelligence engineering, these put these three terms together, and sort of got two things going on. You have an AI engineer, and then you have artificial intelligence within engineering. So a little bit of overlap. So the role of this AI engineer, really, if you were to say what do they do, well, this is what they should do by the output of their work, right? Which is help the decision-making process. And make the outputs better, okay? Improve product quality. So just some of the AI driven design principles, let's say generative design, device design, the human computer interaction, responsibility and accountability, which is an interesting one because it's also problematic, and product design optimization. So we should be able to offer people through these tools, offer people's more options, and with more parameters set, such as type of material and so on. So I'm not sure if people have heard of the term the fourth industrial revolution, but it's certainly where we're seeing the joining of AI and robotics and Internet of Things all coming together to produce something, I suppose, more powerful. So if we just take Schneider Electric, they have the World Economic Forum has just recognized, I think, two of their companies or two of their plants as what they call sustainability lighthouses, right? So IIoT is the industrial Internet of Things sensors all over the place. Robots moving stuff around, all that sort of thing. But these are the outputs that they were able to achieve, right? Power reduction, material waste down, O2 emissions. And also they have an AI system looking at the water usage and quality and reduce the water things. So I'm just going to blast through these last few case studies. These are companies, and they've generated, so JLL have just generated their own GPT that they have. So it's their own large language model that they've trained on specific real estate data, and they are going to be rolling that out for client interaction. Creo measure what you need for quantity surveying. So you sort of set up and draw your building, and then over here on the right you can see you have auto measure, and it will tell you what you need and how much you need and all of that sort of stuff. So very powerful stuff. Test fit for we give it the data that we want to build on a particular site, and you see the things there. It will generate a potential or a design, and then it will let you change it, and it will visualize that immediately, so in real time. Finch, I really like this one. It's sort of cool. You give it the outline of your design on the right hand side, and you can see it, but you can select down the bottom right. You can select different things that you want to optimize. So it's already sort of chosen CO2 emissions, and then we're just about to select daylight. And then when you get it to generate, it produces the internal layout structure, but it uses all the AI tools here on the right hand side to produce an optimized internal model based on the parameters that you gave it. So the AI architecture of generative design housing is something similar, and you can place doors and windows around the place, and it will generate. And just on the left hand side, this is what it was trained on, right? So these are the inputs, are the black ones, and then you have potential outputs, and just lots and lots and lots of that data. That's how it's generated. And just to try and wrap up briefly, the challenges we have are certainly around GDPR. Everything revolves around data. Where did data come from? What's in it? What are the problems that you might face with that data, if any. You got to be careful. We already mentioned that ethical use of AI is something that we have to be careful about. So when an AI makes a decision about something, are we able to explain why it did that? And quite often that's not the case. So transparency is a big problem. In the EU, they've rolled out or they're rolling out the EU AI Act, and that's really going to be all around applying a risk measure against your particular AI system. And then according to the risk level, you're going to have certain safety factors required. And integrating any new system with legacy systems is always a problem, no matter what it is. Okay, so never to be underestimated. Employment, certainly I see it. It's going to automate a lot of things. It's going to replace some things. I don't necessarily see that as a bad thing. I think we should see it as freeing up people to do perhaps more higher level or higher value things. Okay, but increasingly able to do new things like generate drawings. Don't know if you saw this, but here's a autonomous robot. It's called Mama Bear. You can look at the name there. It's sort of cool. But it was trying to design a new shock absorber. Right. So this is what it does. It's a whole system, robotic system, operates on its own. 3D prints the structure, puts it onto a hydraulic press, crushes it, measures the energy absorption, throws it away, takes note of the design and how much the absorption was, then it modifies the design slightly based on that and prints the next version. And it has been doing that for the last 3 years straight, non-stop, 25,000 times so far. We're not going to be doing that. So that's happening. That's real stuff, right? Which is phenomenal. Okay, and I think just about to wrap up here. Professionals should be prepared to adapt to these new technologies. Okay. Ethical, social, human in the loop, I think is the buzz term, really, where even ChatGPT has some human training involved in the responses that it produces to try and help correct the model, if you like.